Hi, Jeff Luff from Alternative Heating and Supplies. I'm going to discuss on how and what options you have of hooking up your boiler to your pool to heat it. The types of heat exchangers. There's several different kinds of heat exchangers, and there's all different shapes and sizes. There's what is most commonly called for heating pools and spas is a tube and shell. The tube and shell is a design system that basically sends your pool or spa water through these ports, the larger ports, to make sure you have the water flow through them. Your boiler waters are going to come in through the top and the bottom in this application. Not all tube and shells are designed the same. This is a tube and shell heat exchanger that I used to sell, but I was getting way too many failures in them. And that's another thing I'll talk to you about, is what makes a good pool heat exchanger from the other ones. In this case, this one comes in from this side and exits this side. And the boiler ports are from the top and the bottom as well. What makes a good pool heat exchanger in a tube and shell is the quality of the stainless steel as well as the thickness of it. In this case, my equivalent heat exchangers that I sell compared to this one is about 40% heavier. So my stainless steel is considerably thicker. That works against me sometimes because I lose some of my heat exchange. However, I would rather have the durability and the longevity of a quality heat exchanger over losing a little bit of heat in the pool or taking it a little bit longer to heat up. That's all the real difference is. Instead of going through unplumbing and replumbing it in and having, in my case, having a warranty and lose money on the steel. You don't want to go through that. I don't want to go through that. So buy a quality heat exchanger the first time, and it makes my life and your life a hell of a lot easier, and the price is about the same. This is another tube and shell heat exchanger. This is a much larger one. This is about 370,000 BTUs. This is enough to heat an average size swimming pool, anywhere in the ballpark of 15 to 25,000 gallons. I can help you calculate that, or the website also can help you figure that out. Basically, the water comes into this large port from the pool, and there's tubes inside this that the water from the boiler is going through, which separates the pool from the boiler water. There's another heat exchanger, which is also a tube and shell design. The pool water comes in at the top this time and out the bottom. The boiler water goes in the sides, okay? The difference with this one, this is what they call a Cooper nickel. Cooper nickel is capable of handling saltwater pools. It can also handle chlorine. It is also a much higher grade heat exchanger. It has the capability of being cleaned. You can take off the top and bottom and get to the fingers that go through the whole heat exchanger. They also come with a CPVC union to take on and off as your season comes to an end in the beginning. And these are considerably more expensive because they can handle the salt water. The stainless steel cannot handle salt water for very long. It can do okay, but in a saltwater pool application, we recommend you go to the Cooper nickel. Saltwater heat exchangers will have a shortened lifespan. Probably a lot longer than most people think, but we recommend that you go right to the Cooper nickel for saltwater applications. On a chlorinated pool, you need to monitor, even with the stainless steel and the high quality that we sell, you also need to monitor your chlorine. The chlorine levels get too high. A chlorine is basically an acid. It cleans the bacteria and cleans the pool. It'll also start to eat the stainless steel if the chlorination level gets way too high. I'll go into more depth in that later. The other heat exchanger is called a plate exchanger. This is one of the ones that most people ask me about because it is considerably cheaper than the tube and shell designs. They're also made from stainless steel. They have a lot more surface area, so they heat faster. The problem with them in a pool application is that the port sizes are only an inch. That means you can only get as much as, depending on the pressure in which your pump produces, as much as 20 gallons a minute, which is not usually enough for a pool. The other problem is they're usually brazed. And when the brazing is done with a copper, and that will also be eaten by the salt water or the chlorination in the pool. So again, these will last quite a while, but they do not last as long as what they're not designed to do this. These are designed to heat up with boilers inside and also domestic hot water heaters. And finally, I get the question of the sidearm, which is also a tube and shell design. Stainless steel, same design as these, are not designed to handle the water flows, once again, that the pool and spa heat exchangers are designed to do. They're also very well made. They also have the fingers and everything the same, but these are designed to run off the side of a domestic hot water tank as well, and they are supposed to work on convection. So they're not designed to have big gallons per water flow. So those are the basic tube and shell, sidearm, plate exchanger. Those are the basic styles of plate exchangers that are applicable to a pool. And I'll go deeper into how they'll apply and the best way to install them. What I'm going to go over now is how to basically install and how it'll look when you're hooking it up to your pool. Hooking up to your pool, as you can see from my, excuse the drawing, but it's the best I can do. You got your basic swimming pool, and it can be in ground, above ground, anything. It's just to give you an idea. So the water will come out of the pool, and it goes to generally the pool filter and the pool pump. Then usually, before you had a heating system, it would go right back to the pool to be filtered back into the pool to keep the water circulating. In this case, this is where you're going to add your tube and shell heat exchanger, or whatever heat exchanger you decide, but we recommend the tube and shell. The tube and shell, as you'll see, it comes in and goes into the heat exchanger and goes back out to the pool after the water's been reheated. It is now hooked to a conventional heating boiler. Okay, this could be your indoor boiler, this could be your outside wood boiler, this could be a boiler of any kind. All right, the water temperature of a boiler runs anywhere from 160 to 180 degrees. That's all we need to accomplish. So the water from the boiler is going to go through the heat exchanger, which is going to exchange the heat from the pool water, putting it back into the pool, and then returning to the boiler to be reheated. So the heat exchanger sits there. In this process, we're also going to mount after the filter and the chlorinator. You don't want it in front of the filters. You want the water to be filtered first, the chlorination added, then into the tube and shell heat exchanger. In the process here, we're going to mount a T, where we're going to mount a thermal well, which is going to go into the water of the pool, which is going to be where the temperature probe of the aquastat, which is going to regulate the temperature of the pool, which we have kits which we can supply that will simplify this whole thing. And that'll mount in here to monitor when the filter should be on and when it should be bypassed. And I'll go in a little more detail. So when the probe senses with the aquastat, which the aquastat looks very similar to this, the ones that we sell. There's many different kinds of this variants. The probe, which will go into the thermal well, will read here, and you set your temperature of your pool to, hypothetically, I like 89 degrees. A lot of you are probably thinking that's a little warm, but it's where the wife and the kids are the happiest, and that's the most important part in life. So once this aquastat says that it's 80 or 88 degrees, it's going to turn on this three-way valve from the boiler and say that I want the water to go through the heat exchanger and then back to the boiler to get reheated. When the pool is and the temperature has been accomplished, this is going to read 89. It's going to say we're all set. It's going to tell the valve to shut this way, and it's going to send the water from the boiler back to the boiler just to bypass the heat exchanger. That's how we determine what the pool water temperature is. The pool filter, since we cannot control when the pool filter is turning on and off, we power the aquastat and the valve by the pool filter and heater, or the pool filter and chlorinator. Whatever you have 110 or 220 volts going to that thing. So we're going to power the aquastat and the three-way valve by this. So when the pool filter's on, the heating system is activated. Now the reason you want that to be powered while the pool filter is running is if this is sensing the water is cold and the pool filter is not running through this loop, the water is going through that heat exchanger, which is heating up the water in the pool side of the heat exchanger, which is heating the water up to 180 degrees, which is doing nothing. And depending on the PVC and the piping that you have in the pool, that water will slowly heat up and get pushed towards the pool, which pool liners and pool things don't handle those kind of temperatures very well. That's why we only want the water circulating in the tube and shell heat exchanger while the pool filter is running. I hope that makes sense. If not, just give us a call and we'll explain it in more depth for you. So with the power of my aquastat and everything running off the pool, it only is going to run when the pool filter is running. And no, you do not have to reset the digital aquastat every time you power on and off the pool filter. It does keep the settings that you have made. Okay, so with the boiler now, all it's doing is bypassing the heat when the aquastat calls for it, or sending it back through the tube and shell saying I need heat in the pool. It's just that simple. I know I would like to make it sound like it's more complicated than that. It's really not. Check out our kits, check out our catalog and our website. It's alternativeheatingandSupplies.com. And our catalog, which is also can be found at the very top of our website in the center, and you can download it. Or just give us a call. We'll put one in the mail for you. Have a great day.